Hey everybody, I wanted to do a quick video about these speakers and a problem I was having and how I fixed it. This is a JBL LSR4328P. Very similar to the LSR4326, which is the 6-inch version. This is the 8-inch woofer, and it's a really cool speaker that can take a bunch of different formats from analog, digital SPDIF, AES inputs, and connect with the other speaker over a high-Q net, which is like a JBL Harman Kardon interface that lets them turn on at the same time and share settings, which has been really handy. I bought these secondhand. They're normally pretty expensive. I got them very cheap, and they sounded good when I bought them, but then spent some time on my desk on the off standby plugged in position, and when I came to listen to music one day, I was only getting distorted digital artifact audio out of this one, and I attempted to do a firmware update on it because I thought maybe the firmware got corrupted. There's unfortunately firmware in the DSP of the speaker, and it would only take the first half of the firmware update and then it would crash. So if that sounds like something you've experienced, you may have the same problem as me. However, I then performed a fix. I found some bad capacitors, and I'll show you what that looks like. But now its brother sounds kind of dull and muddy by comparison, and also very low volume. So as one could reasonably assume, the capacitors are going bad at the same time. So what I want to do is follow the process I took to open this one with its brother and show you the process on camera as well as the fix. Doing my best to eliminate something that's a little bigger than what's normally on my desk here. Like I mentioned, there's a lot of input options on this from analog input. This is actually, I think, for a reference microphone, SPDIF, AES, high-Q, USB for your firmware updates. And the first thing I would probably check if you're having a problem and you've had like any kind of power spike or the speaker just isn't turning on at all, is there is a fuse inside. Let's see about this one. Yeah, so there's actually a fuse, and they've included a spare fuse here. So this is the one in use, and the spare is inside that container. Now this one turns on, so I'm pretty confident that is not the issue. Again, this is the one that's just sounding kind of dull and muddy. Now, what I'm going to do is start removing these 6 exterior screws. You don't have to do any of the screws on the bottom. Those are for mounting. As I wrap up these screws, I'll start to tell you about the first issue I had as I was doing this with the other speaker. Which is that it was damn near impossible to get the back to separate from the cabinet. By that I mean, I even tried dropping a wrench into the porthole so that I could expand it and pull up from the inside of it. Okay, we're back, and now we're going to begin a process that a lot of you are going to scoff at, but let me give you a perspective. The previous speaker was non-working, and so it was either going to be e-waste if I couldn't get this back off, or that was it. So this one is working, but it's very low volume, sounds dull, and it needs to match the other one, and I've already opened it before, so I'm kind of ready to just do what I need to do to get the back off. So I'm going to show you the best 100% safe way. Definitely not manufacturer approved, but this back is inset a little bit and then touches a gasket that I think has turned into a heavy-duty adhesive. So what I did previously is I took a drill. You have to do this from the porthole side. Don't do it from this side. This is where all the electronics are. There's nothing up here. we're back, and I'm going to start to open this really slowly. And really the main concern is a digital, I've heard them called ZIF connector style ribbons that connects to the board. And so you can see one of them coming out here. If we lay this part on the lip over here, can't quite see. There you go, on the lip. And we start to tilt this up, we see this ribbon connector right here. Okay, so let me see if I can punch in on this at all. This might be difficult to do with one hand, but what we're gonna do is pop out this lower layer, which is holding it in. Just use a fingernail. We do the left side, we do the right side, and the ribbon falls right out. So trickily, when we put this back together, that will have to get clipped back up. And I will show you why this is such a big problem after we disconnect. So these are not as easy to damage. Here is the tweeter and the horn, which are together. This one has connectors on the two sides, but they have covered it in an acoustic foam to keep it from rattling. This side, yes, okay. Going at this all wrong. All right. So two clips. Essentially looks like this, and those clips on the outside hold this in. And again, this is the tweeter and the woofer. Okay. On this side, we have similar PC part style connectors. Should be considerably easier to work with because there hasn't been a whole bunch of adhesive applied. And at this point, I believe we are free. And we can pull this whole part up. I'm just gonna lay this right back on top. Okay, so this is the DSP board here. And again, we have a connector over here. Could be wiggled out and disconnected. That's the not the only connector, because we got to get this ribbon cable over here. It's similarly a situation where we get in here with a fingernail and pull this ribbon away from the board. Okay, then we're removing 4 screws. And now we're going to remove 1, 2, 3, 4, 5, 6, 7, 8 screws, and then there's going to be an additional 4 that are on the ground bar. It's worth noting at this point, because this has been plugged into mains power, we want to be incredibly careful not to bridge any of these pins, or really anything. Yeah, so here's 1.5 volts. These are a couple of the bigger capacitors, I think. 1.5 volts. So what I did is I created a little tool to discharge these capacitors. This is alligator clips, cut in half, resistor in here. I've covered up pretty well. So this resistor can drain some of that voltage. This to this is half a volt. Now, this is not a verbatim reading because we're actually operating in parallel here. But you can watch that with the resistor attached, we are starting to dissipate some of this stored capacitance as heat in the resistor. We'll just wait until this goes down to near 0. I mean, that is a non-consequential amount of voltage. We'll do the same with this one. protected down below 0.5 volt. Now, if you don't have access to these tools, I mean, a resistor with probes, what you could do is leave it unplugged for a considerable amount of time. Because I was waiting for parts, it was about a week before I started on the previous one, so I really went in there with a lot of confidence that it had been discharged. Okay, so now we come to one of the trickier screw removals. In here, there are on each side 2 screws that connect to a load bar rail here. This one is easy. The other one requires something with a little bit longer throw. I have to remember what screwdriver I found that allowed me to do that, because this one ain't it. This board should pull largely away, except for this ground pin right here. This grounds the circuit board to the metal frame of the back plane, and is another good place to alligator clip to discharge that current with the resistor. But I think we are good on that front, so I'm going to pull this up and away. Okay, here's where the plot thickens. The capacitors that I removed from the last board looked like this. They are CD26L, 16 volt, 1000 millifarads. The capacitors that are on this board are different, which means someone had already been in this speaker and done the capacitor replacement, but of the 3 of this type on the board, here, and over here, they only seem to have replaced 2 of them. So I think it makes sense to just do the replacement with the 3 that I have, largely for the sake of consistency, because we're talking about reference audio. So I have some flux I'm trying to finish. This is a solder sucker, so come in with this, melt this solder, try to melt it really good. It's pretty close. Right off. Here's our second one. Boop. Okay. Now was a tad tricky. Let's figure out. There are a couple that look similar here. That being this one. I think this is the one that we need. Yes, these are 470 farad, 35 volts. This one is 1000 farads, 16 volts, CD26L. So, what I was told by people smarter than me is when you go in and do this, you just take out the ones that are matching. Well, you can doubt my methods, but we got them. All right. With these capacitors, we do have positive and negative legs. The negative leg is shorter, and on the board, the negative, I believe, is denoted with the dark side here. You can see a plus up here. So this plus means the long leg is going to go in this hole, the short leg is going to go in the hole below it, and the opposite is true on the other side. So what I learned the first time, because there's still a little bit of solder on here I haven't been able to remove with my solder sucker, I'm going to cut these down, pre-cut them, keeping the short leg short and the long leg slightly longer. And what I want to do is push this through in such a way that I can heat this first element. Unfortunately, I don't have desolder wick, which would solve this problem, but just heating it up, it pops right through. And then short leg is in position to do the same thing right here. If I heat it a little bit, I think the short leg is going to pop through. Okay, so now what I've got here, brand new, in there. That is not soldered on yet, so we are going to apply some solder. If you've never done this before, this is probably not where you want to start, but make sure you heat the component and the board. Because if you don't do that, you get cold solder joints, which essentially means you just get a hardened blob of solder on your component that is gonna fall off and break apart. And it might make a connection for a second, but what you're seeing here are pretty good connections. And I can come in, snip away the excess, knowing that the polarity is correct. Okay, so we're going to do that a couple more times. Again with this one. I'm going a little quick here. Believe me, the first one I did here was not this quick. Actually, one of the things I learned is my iron was at way too low a heat. I was struggling a lot, and I was kind of feeling like the doubting whether my tip was working correctly, because I thought my tip was just really oxidized, which is probably a little oxidized. But no, it turns out I was running this Weller soldering iron at like a 4 and some, and it was plenty enough to heat solder in general, but not quite enough to do what I needed to do here. Okay, So again, I've got we're settled in here. I've got my legs popping out, but we're not done. Don't forget to add a little fresh solder while touching the joint and or rather the component and the board. Use this opportunity to cut this back. Cut this back. This one actually cleaned up nicer. This one can pop right through. Bottom one needs a little bit of heat to be able to pop through. Okay. We will, a little bit of flux could be used here too, just to reheat everything, but kind of appears everything's working pretty well as is. I think I am going to use a little flux because I didn't I pre-fluxed this area, I guess. Good. Listen, this is not my strongest skill set, but at the end of the day, gets the job done, right? You can clean this up with isopropyl. What I have is these little pre-made wipes. So I'm just going to wipe down the areas I've been working in here. Try to wipe down the area. And I'll say, whoever did the first replacement of these toasted up this board pretty decently as well. So I feel much less bad about my own skills. Okay. With that, take a look, because it's the last chance before it goes back in. Firm up anything. Also, we can always look at these other capacitors. I don't have these on hand, but something to think about. What I noticed with these original capacitors here is they were bulging. And I'll put up a photo of those. So we'll turn off the iron, clean some stuff up, and get to reassembly now. So at this point, I just want to, I kind of reassembled backwards, but I want to show how I reconnect these ribbon connectors. This is kind of the most tricky part, probably. Well, we've been through some stuff. This one actually has a kink right here, which I'm not in love with, but given the circumstances, I'll allow it. If this seems difficult to see, it's because it is. What I'm going to try to do is reach in there, find that ribbon connector. I'm going to pop it in. This. Lock it down. It's secure. Okay. With that secure, we can cannot do very much yanking on any other component. So just a quick update, I did get everything reassembled. The speaker sounds awesome, and I applied the latest firmware update. So this was 100% a successful, worth doing repair.